Okay. Hello and welcome everyone to the day three of the DP 900 bootcamp. So I'm Chanchal Bansal, Microsoft AZ lead for the quality reason. I'm welcoming you all to this session. I hope you have all the learnings from the previous day one and day two, and we will be covering the remaining topics which are needed for the DP 900 exam. And we have for that today we have with us Akram Mohammed, who is a working professional at Microsoft, who is working as a support engineer. So I would like to hear more about him from himself. So Akram, can you please introduce yourself?
Yeah, sure. So, hello everyone. I am Akram Mohammed, and I'm currently working at Microsoft as a support engineer for M365. I'm also an electronics and communications engineering student, and I just love to learn stuff, and I love to understand how things work. So, yeah, that's a bit about me.
Perfect. I think we can start with the presentation and go through the whole session. So yeah, you can take up the session. Over to you.
Sure, sure. Thank you so much, Chinchal.
I
I will.
will drop
Yeah.
in. I will tell you all the questions and queries that we will be having during the session
Okay.
through our live chat.
Okay. Sure. Thank you. Yeah, I will share my screen.
Okay, perfect.
Yeah. Let me know if you can see it.
Yeah, it's visible.
Okay.
Perfect.
Okay, cool. So today I will be starting off with, of course, as you all know, it's Data Fundamentals 900. And from the past sessions, I think we must have already covered the core data concepts, relational data in Azure, non-relational data in Azure. So today I will be focusing on the data analytics in Azure part. So I will go through all those things, what you need to keep in mind when it comes to analytics, whether that be in Azure or outside of Azure. So moving forward, so I would like to start off with like coming from behind. Before getting all that data, what's our end goal? Our end goal is basically to analyze the data. It's basically to get into a position where we can have the data tell us what has actually happened in our business or in our product. We need to get into a situation where we have enough data to tell us why that particular thing happened, or we need to have predictive, meaning we need to have enough data to tell us what is going to happen in the future. That's where we have our machine learning and those things come in. And we have prescriptive. So if I want a particular outcome in my product, if I want a particular outcome in my business, then what should I do? So you need to have data which will help you do all of these things and which will help you to get all of these different outcomes, right? So that is what we have when it comes to uh, analysis, right? Okay, so next, coming to business intelligence, what it's about is, if I'm having a product, I will start off by planning, and then after you plan, you basically gather data, and then you analyze the data, and based on that data you take business action. So the important point here is that, once again, the business action which we take, that action is based upon the data that we have analyzed, and we have to make sure that that data is correct. That data should be uh, good enough that it contributes to the growth of the company. So the analysis which we do, the basically the final results which we have in our data, we need to convert that into business action. And then again you gather some more data from the product, again you analyze that again, and then you convert that to business action. So that is basically the cycle which a product has. And what I'm going to do in this lecture is take you through that process and take you through the most efficient way of getting data and getting to a point where you can take business action with that data. I will give you a couple of real life examples where people are actually taking business action as a result of the data which was analyzed. So I will come to the modern data warehouse. So I want you to focus on the leftmost part. Let me just take a laser pointer. I hope that laser pointer is visible. But I want you to look at part one, the leftmost side. So on the leftmost side, what you have is you have your data sources. which are basically the sources of data, which can be SQL, it can be files, it can be anything. So that is where all the, for example, let's say you have a banking system, or you have, let's say, an airline ticket booking system, and you want to store all your data. So all those things are stored in the part one. So you can have your Azure SQL database, everything is stored in rows, everything is stored in such a way that you can read it, you can update it, you can delete it. And that's the main purpose of the data source. You want to be able to read, update, delete. It should be quick, it should be fast, there should be atomicity, there should be consistency. So that is what is kept in mind when you are at step one, basically, at the first part of this modern data warehouse. So you have all these different sources. It can be, let me see, I have some examples here. You can see here, just look at the left part. You have Oracle, you have SAP, you can have SQL Server, other bunch of other different databases. That's what we have, and that is what's there in part number one. And from there, this number two, this part two, this is what's the data warehouse. So you have to bring data from these different sources, and you're going to put it into a modern data warehouse right here, which is in part two, which I'm going to get into as well. And then in part three, that is actually a bit is different. So you can look at it left side different and right side different. So when it comes to the left side, you're thinking ETL. You're going to extract it from the source. You're going to transform it on its way before it reaches the data warehouse. Okay, so before it reaches the data warehouse, the ETL is going to happen, and then it's going to reach the actual warehouse itself. So the question you might ask, why not, you why not use the source itself to analyze the data, right? Like in this image, you can see that we are pushing it to the data warehouse, and then we are analyzing it at step number 3 and step number 4. You're analyzing it, but you might think, why not analyze it directly from the source? So what, like, in before people you thought of doing that, people actually did that long, like maybe 10 years back. They tried to do this without using a data warehouse, but what happens was, it's actually, it didn't work. The production system, it went down, because what you're basically doing is you're querying the the source database itself. You're querying the main database, whose job is not actually for analyzing and computing queries. That source is responsible just for maintaining the right data. If people are having a banking system, then they need to keep track of the transactions, who has how much of money, who gave how much is left. So that's what the part one is responsible for. And if you try to query that itself, now you're putting an additional load on the source, and that's what causes a problem, and it causes the source itself to fail. So that's why the best practice is to move that data, extract it, and then bring it to a data warehouse, which is in step 2, right? And I'm going to go through what happens between step 1 and step 2 in a while. So now I'm going to move to step 3. So what this step 3 is, you have a data warehouse, which is basically, it can be hardware. There's going to be a couple of providers. Maybe IBM is giving you a data warehouse, maybe Azure is giving you a data warehouse. But what exactly, like, how is it built for querying? It's built for something called, you have OLAP and OLTP. So the sources which are on the left, they are OLTP or optimized. They are optimized for transactions, as I said, for reading and deleting and maintaining that ACID properties. But on the right, on point number 2, you have the OLAP, which is optimized for querying. So how is it optimized for querying? OLAP is basically a software. Think of it as a software which is there on your warehouse. So there is a piece of software which is there on your warehouse, which stores the data in a format such that it can be queried faster. The step number 3 is basically that it's a model. It's basically an OLAP cube. What that is it takes that data warehouse, it takes that data. So here is a better slide. It's basically the same thing, same slide, same contents, just it looks better. You can say that you have the OLAP cube, which is on the right, that purple color thing which is there. So that is a piece of software which uh, which basically makes the data warehouse easier to query. So you can see the points. The goal of OLAP is to pre-calculate and pre-aggregate data to make analysis faster. So whatever you store in the data warehouse, you're going to the OLAP or the nature of the data warehouse itself is going to be such that the contents are already going to be pre-calculated, they're going to be pre-aggregated, and when you query the data warehouse itself, that's going to be much faster, much more efficient. And the OLAP cube is a screenshot of data at that specific point in time. So this image which you're seeing right now, you can see it's basically it has more than one dimension. On the left, you can see the name of the product, and then below you see geographies, and then you also see time. You say, yeah, maybe quarters. You can divide it by quarters. So aggregated data per country, per quarter, per product is basically stored in something in this kind of a array, or in 2D array, or even more dimensions than that. It's stored in this kind of an array so that it can be queried faster. So this is what the software of OLAP is doing in order to achieve, in order to get these, in order to just be efficient when you query them. Okay, so step one we have gone through in just brief, not that much detail. I will go in more detail. We are at 2, and then we are at 3. Okay, and then right. So I'll just quickly go through OLTP and OLAP. OLTP was basically the sources which you saw on number one. These are all having, these are all OLTP based. Most likely these are all OLTP based. They're optimized for transactions, and here you're optimizing it for OLAP, which is for analysis. And this is just a table. The OLTP contains current data. You are dealing with something which is very important for the product. You have to get it directly. And on the warehouse side, it's historical data. It doesn't need to be that current. You can load it slowly with the help of pipelines. And then on the left, you can see OLTP. It's useful for running the business. And then you have relationship models. It can be a relational database, and it can be whatever you make of it, OLTP. And then it provides highly detailed data used for writing data. And then its size is small. It's not that large, because of course, if you want to query it, it needs to be short, because it's directly connected to the app itself. It's directly connected to your phone, and if you request something, the users would want it to come fast. So if you have a huge size, then of course no one would want to query such a large thing when you're doing something in production. And that's why it's fast. It provides high performance. And you can see the content, the OLTP, the number of records are just in tens, whereas compared to OLAP, it's accessed in millions, right? And OLAP is flexible, but it's not fast. And you can see the OLAP's warehouse, it ranges from 100 GB to about 1 TB. So you can see the size of that. And OLTP, you see the bank transactions they are made by the customer. That is something which should be fresh. It should be correct all the time. Whereas if you want to do analysis, it doesn't need to be that fresh amount of data. And for example, bank transactions which are made at a particular time, and if you want to query that, you have OLAP, because you pulled that data into a data warehouse. Okay, so what we saw, so we are still on point number 3. We are still in the right hand side. So what I talked to you about was an OLAP cube, and of course, as time goes on, people start to innovate more, and new things come up. So another way of doing things is with the help of a columnar DB. If you've heard of a columnar DB, that is also something which is applicable to the data warehouse. So instead of an OLAP cube, you have something called a columnar DB. So before going to that columnar DB, this is what the OLTP side, the leftmost side, has. This is a normal, you can say, a row of a column, a row of a table basically, and then you have you can look at the numbers 512, 513, and this part at the center. You can see how it's stored. You have the number, and then you have the bowler, you have apparels. It's all in a single line, right? And this is how it will be on the source part and on the transactional part. And now if you read the top, it says all fields in each row are important. So for OLTP, it makes sense to store them on the disk by row, with each field adjacent to the next one, right? And transactional data is also characterized by frequent writes and frequent writes of individual rows. So that's why they store it in this manner. And also not all of this data which we have in the source, not all of it which is in the source on the left part, not all of that is important. So not all of that goes into the data warehouse. That's where the transform part comes in, which I'll talk about in a while. But right now, columnar DB, what happens there is you can see instead of having everything in one line, you're just having all the IDs together. You're having all the names of the products together, or you're having all the same column together. That's what a columnar DB does. And when you do something like this, it makes it easier for you to do analysis of a particular column, because when you do analysis, what happens, you don't usually look at the entire row. You basically want sales, then you just look at the sales column, right? So and then if you if you store it in this manner, then that's what basically the data warehouse does. As an alternative to the OLAP cube, you can store it like this, and this is also really fast, right? And as you read it, you can see it reads it together in a single block. You get performance wins both by retrieving information that's grouped together and not retrieving information that you don't need, such as individual names and stuff like that. So mostly we have these columnar DBs, and we don't use OLAP cube that much, because you have to keep generating a cube, basically. So you have to basically adjust, what do you want? Do you want this or do you want that? It's totally based on your requirement and what you like. So you can choose your products based on whatever your business need is. Okay, so again, these are all similar diagrams, just different way of saying it. And then you have data. Data first needs to be integrated and processed before the visualization takes place. Okay, so the data sources are too valuable to visualize data directly from them. You can see there's an X mark, so you're not directly querying that source. You're just going through the warehouse and then storing important transaction information, and then the data warehouse makes sure that data from multiple sources is integrated. So if you directly query the source, then things are not integrated. You might have some data in a different database. You might have some data like all spread across in different databases based on your requirement. You might have NoSQL unstructured data. You might have structured data, relational data. It's not integrated if you directly query the source. So if you put it in a data warehouse, it's basically total integration of all those sources. And when you want to visualize something, you just get it back from the data warehouse itself. Okay, so we have ETL, extract, transform, and load. So where does this come in the overall picture? So we are coming from the source, and before we put it into the data warehouse, we have to do extraction, transformation, and loading. So you extract it from the source itself, and then you do some transformation. Why do you do the transformation? It's because you don't want to have all the data which is there in the source database. You just want certain columns. You just want relevant columns, which are relevant for your analytics. You're just going to pull that. You're just going to extract that. Basically, extract everything, transform it, and then load only the things which you want. So that's where ETL lies in this diagram, right? So you have extract from various data sources, transform data to meet your requirement. So what are the tools you can use to transform? You can use notebooks, you can use Databricks. What is notebook? I think I have a quick picture about that. I'll show you. Like, these notebooks where you press run and you just run that small piece of code. That's what a notebook kind of is. You can run Python code, just running a particular snippet. So that's what a notebook is. And all of that will come within the transform part of the ETL. And once you've made data get into the form based on your requirement, then you can load it to the target data warehouse, to the data lake as well. Okay. So two common types of analytical data store. So the data store, basically I'm talking about this warehouse which we are in right now. So when it comes to that warehouse, it can also be a data lake itself. A data lake, this will help you if you want to use NoSQL, which is unstructured data. That will help you. So if you're having something which is SQL based, you just want to put a table in, then you can use a data warehouse, which will be more relational. and you can query faster if you use a data warehouse because it's optimized for that. It's a relational database, and data is stored in a schema that is optimized for data analytics rather than transactional workloads. So that's data warehouse. And for data lake, as you can see, it's high performance, and it's a mix of structured, semi-structured, and even unstructured data that you want to analyze. So based on your requirement, you can choose whether you want a data lake or whether you want a data warehouse. Okay, so the data pipeline. So as I showed, and once again moving back to that diagram, because that diagram seems to be pretty important, because all of the things which we are discussing right now, it falls into this main parent diagram which we have right here. Back again to these sources, and then this is where the pipeline lies. The pipeline lies between 1 and 2. The data pipeline, the entire data pipeline lies between 1 and 2, which is basically the source, and you have the data warehouse. So after it reaches the data warehouse, that's when it goes to Power BI after that for the analytics and creating reports. So before that is where you have the pipelines, the activities, the transformation, and all the loading happens over there. Okay, so the data producers, that it can be databases, it can be sensors, it can be logs. And once you go to the data pipeline, it becomes like an orchestration. So what an orchestration is basically, you must have seen a bunch of singers, all led by one singer alone, who will be having a stick in his hand, and he will be moving the stick up and down, basically. And based on the movements of the stick, the singers will change their voice, they will play a different kind of a tone. So that's what data pipeline kind of does. It does that orchestration in terms of it will control all the data coming in. Let's say we take Oracle. So the data coming in from Oracle, it passes through a pipeline which goes to the data warehouse, and on that pipeline you can do things like time it. For example, if I say this Oracle thing, I want it to extract from Oracle let's say every day at 9 p.m. I want to pull data from Oracle and I want to put it into my data warehouse so that I can analyze it. And then that timer, you can set it through the pipeline, and that will be through Synapse. I'll get to that as well. So for SAP HANA, you can say that I want this data a bit more regularly. Every 2 hours, I want to extract it and then put it into my data warehouse. And maybe for this SQL server, you'll say I want this to be even more frequent. Or if you want real time, that's when you can have Kafka. Kafka will also come into the pipeline part, and that would be more of a stream kind of a thing. So it will be continuously moving in from Kafka. It will get prepared in Kafka, and then it will move into the data warehouse continuously. So all of those technologies, like stream processing, and then you have stream pipelines, and you have the real time pipelines, and batch pipelines. You have batch pipelines and real time pipelines. So that all will come in the middle before it reaches the data warehouse part. So where was I? Yeah, right here. So you have the batch ingestion, meaning you're pulling the data from from databases in batches. But if you want it from sensors, if you want it real time, then you can use stream ingestion, and it gets into the data pipeline. And then you can use yeah, of course, Kafka, and then from there it moves to the data consumers. So the consumers, you will have your data warehouse, you'll have the data lakes, and from there you can pull it to Power BI once again. So that is a high level view of the data pipeline. Okay, so and within this data pipeline, you have activities. Okay, so before going to the activities, I think, okay, I'll explain Azure Synapse. Okay, yeah, analytic workloads on Azure. So these are all the different products which Microsoft has. If you want to use data, basically, if you want to play around with data, if you want to pull data from here and there, and you want to analyze it in some way or another, the one which I will be focusing on in this video is basically Azure Synapse Analytics, because that is basically a mixture of all of the other services which we have. And I'll show you how. You have Azure Machine Learning. You can do machine learning in Synapse itself. You have Databricks. You can use notebooks inside of Synapse itself, right? So what Synapse is basically the main selling point of it is integration. You can do extraction and transformation and loading within the Synapse workspace itself. You can create notebooks within Synapse itself, and you can push it to Power BI through Synapse itself. And of course, and then the other services, just have a go through of that as well. Event Hubs, Data Explorer, and then you have Stream Analytics, Graph. Yep, and all of these things, you can check out the link which is at the top of the slide if you want to have a look at what all the offerings Microsoft Azure has for data. Okay, so coming to Azure Synapse Analytics. Okay, so before that, questions, if anyone has any questions, do you want me to take any questions?
I guess there are a couple of questions. Like, first question is, can you hear me, Akram?
Yep, I can hear you.
Hello? Yes. Okay, perfect.
Yes.
So, first question is, do I need to create OLTP database or it's already
Yep. Okay, so to create an OLTP database, that is basically, you can use Azure SQL itself. You can create it by yourself. It's there in Azure. Of course, you can go and provision that database and you can connect it. And the next question which I see is, how can I integrate different databases? So to integrate those databases, that's what I'm coming to. We have Azure Synapse Analytics. So you can basically integrate the source database and your data warehouse. I will show you how to do that in the upcoming slides.
perfect?
Okay. Yep. I don't see any other questions. Okay. Yep, I'll continue with my slides.
Yeah.
Okay. Yeah. So Azure Synapse Analytics. As I said, it is an integration of all of the different products or all of the different things which I need to extract, transform, load, and then analyze my data. It's a complete package. So one part of Azure Synapse Analytics is the storage account itself. Because if you want to store something, of course, you would need a storage account, and a data lake comes inside Azure Synapse Analytics by default. So every ASA, Azure Synapse Analytics workspace, it needs a data lake to be set up and configured. So every ASA will have one primary data lake by default, and it's a general purpose. You can have files, shares, queues, tables, containers, and all those things will come in along with the Azure Synapse Analytics uh, workspace. And then also with Synapse Analytics, you have the option of using Azure SQL pools. So if you looked at uh, the diagram which is right here, you just see one data warehouse or one data lake, basically a data lake, data warehouse. As I explained, based on if you want relational or unstructured, whichever one you're using, you see that you just have one of them. And let's say you want to have more. If you want to do a lot of data visualization and it's more frequent, then let's say you want more storage and you want more compute. So for that reason, you have something like within Azure Synapse itself, you can provision Azure SQL pools. So what that is, it's going to be a bunch of SQL servers which are going to be parallel processing. They're going to be parallelly processing so that any query that you run, instead of going to the single data warehouse, it's going to have uh, extra compute power. You have more SQL, more power, more SQL pools, and it's a relational database. It works well with star schema, and then you can quickly run complex queries across petabytes of data. So the thing with Azure SQL pools is, of course, you can directly query the data lake or directly query the data warehouse itself to analyze the data. But if you want more processing power, you have to start Azure SQL pool. And if you start it, of course, it's going to charge you money. And this will charge you money. This will charge your Azure account based on how much time it's turned on. So if you want to run a query, you have to turn it on and then run a query. And then if you want to save money, of course, you're going to have to turn it off. Then if you turn it off and let's say you want to use it again, then of course it's not convenient, right? If you want to use Azure SQL pools. But if you really, really need this extra power and extra processing, then you won't mind using these SQL pools. And that's why we already have the data lake storage account, which will be there always, but you won't be charged for it being on. It's going to be charged per query that you run. right? So Azure SQL pools, this is not per query. This is based on how much time it's turned on, and of course the ingress egress that would also be there, I'm guessing. But this you don't. But the warehouse, the lake itself, you don't have to pay for it being there. You just pay for the data which goes through it. If you run one query, how much data got processed in that one query, you just pay for that. So based on your requirement and based on your convenience, you can use whichever one you like, the warehouse or the SQL pool. Okay, so Synapse notebooks. These notebooks will give you the capability of cleaning, transforming the data. Actually, you can use notebook itself instead of using the entire pipeline. But the advantage of using Synapse Analytics is that I would quickly go to this diagram right here. So what Synapse Analytics does is, since it's integrated everything, you have the notebook in the same workspace, you have the data warehouse in the same workspace. So when you transform the data, you don't have to have the hassle of maintaining credentials. You don't have all those different issues which come in when you have to go out of the network to access something else. You need to verify that it's you, and you have all of those things. And since it's all on the same workspace, you can just quickly use your notebook to access the stuff which is in the warehouse. You can quickly use your notebook to access the stuff which is on the data source. You can just move things around very easily. You can bring it to the data source, and then you can query, you can transform it in the notebook and then put it back in the warehouse itself, right? So these are all the advantages that Synapse brings to you, because it has integrated everything within one complete workspace. So you don't have any problems when you transform the data and when you load the data. Yeah, notebooks give you the capability of cleaning, transforming the data, and you can also build your ML models within Synapse itself. So you have the data in the data warehouse, and then you can run a model using that notebook. As I said, those snippets of code where you run that snippet, you can pull stuff, you can create data frames, you can bring things together, and then you can run those models and then put it back into the data warehouse. You can store them uh, all within Synapse Analytics itself. And we have Power BI integration. So without leaving the Synapse workspace, you can see the Power BI reports within the Synapse workspace itself, just by clicking a few tabs. Right? You have the home, you have data, develop, integrate. If you look at the leftmost, you have your data, you have your Azure Lake, right? And you have all these different what is that files? These are all different files. And if you go to monitor, you will find your Power BI inside that itself. So you're going to have Power BI also there, and you're going to have your workspace. You're going to have your warehouse also within that same Synapse workspace itself. So that's going to be very convenient. So if you are a data analyst, or whether you are someone who's just responsible for cleaning the data, all of you can work together within this same Synapse Analytics workspace itself, and you can create reports, you can edit these reports, and of course Power BI, you can use it on your mobile phone as well. I'll get into the Power BI section in a bit. Yeah, okay, so back to this image. So this is basically the console of Azure Synapse. On the left, you have the home, the data, develop, integrate, monitor, and manage. So when it comes to data, you have all the stuff which you have linked, right? You have your Synapse primary lake. So this is the lake which you have, and inside that lake you have these data which are on the right. And for each data, for each CSV file, or you have that paraquet file. I think that's the most convenient file. It's pretty quick. So if you store data in a .paraquet, so you can just click that file, right click it, and then you can create a new SQL script which will run on that data, and you can create a new notebook for that data itself. It will give you the connection URL for that. Just if you click that new new notebook or new SQL script, you will be directly connected to that data. And once you're directly connected, you will have something like this. So if I click new SQL script and I want to pick up the top 100, so within the Synapse console itself, I will be able to select the top 100, and you can see you have the from bulk. You can see the Synapse workshop. It wrote that automatically, right? You don't have to write it yourself. It's all built in, and you have it will select the top 100 from that area, and it will show you the results. Unfortunately, I don't think I have included that slide, but if you scroll down the console, you will see the results of the query which you ran right within Synapse itself. And right here, you can see it's connected to built-in. Built-in means, as I discussed, you had SQL pools and you had the data warehouse itself. So built-in means you're going to the warehouse. You have not provisioned any SQL pools which are going to run this for you at a more parallel processing at a more higher rate. This is just you querying the data warehouse itself. So when you query it, you can see if you go to monitor, there is a tab for monitor. You will see all at the topmost, you see SQL pools, analytic pools. You have the SQL pools. If you click that, you will be able to provision an SQL pool. And you also have Apache Spark pools. So for running the notebook, if you want to do machine learning, you can provision a new Spark pool, and that would be connected to your notebook. And if you run any ML model, you can use that Spark pool to as a compute. So that would be, as you see, that's also within the Synapse workspace itself. And then you have the SQL requests. So all of the requests which you had, all of the queries which you did, are going to be shown here in the SQL requests and in the monitor section. You have those request IDs, and then you have the request content. You see select top 1,000, obviously create a table. The time in which that query was run is also there, and you will also see the duration for which it ran, and the most important part, you see the data processed. So for that particular query, you can see the one which is highlighted. It says 84 MB, and you can analyze yourself how much would it cost. I think I have wrote down. Yeah, I don't remember the exact cost, but it's not high at all. So basically, I think you can run a good amount of queries, and you can still make sure that's very cheap if you're not using an Azure SQL pool. And you can of course look at the amount of data processed, and you can optimize your data warehouse based on this data. So this is the most important thing. So you see that a particular query is processing a lot of data, right? So suppose you're going down here, you're monitoring something, and then you realize that, hey, this query is doing too much. I don't want it to, process so much amount of data. So what you can do for that is again go back to your notebook, right? Let me see where is that notebook slide. Okay, either way. So you can go to that particular thing which you queried. You can right click it, and then you can open it in a notebook. Now, once you open it in a notebook, you can look at the data which is there in the lake. Let's say you want to, let's say there is a company which has 10 years worth of data which is stored inside a single folder itself, right? So there is 10 years worth of data which is stored inside a single folder. And if you do a query on that single folder, what's going to happen is that it's going to go through that entire folder, right? So you don't want to query the entire folder. So you can create a notebook, and in that notebook, what you're going to do is you are going to link it to that folder, and then you are going to split up that data based on, let's say, month wise. So automatically what it would do is it will create separate folders. Okay, yeah, I think I went a bit ahead because I have slides for that as well. So I'll get to that once again. Yeah, as I see, you have the SQL pools right here. You can see the built-in pool, and you have a dedicated P1 pool which is here. This is serverless and one is dedicated, and you have cost control. So that is also another panel which is built in to Synapse as well. You can see the cost wise. You can put alerts. You can set alerts saying that, okay, I don't want any query exceeding this much to run, or per day I want only this much data to be processed. You can set those limits within the console itself right here. And pipelines, yep. Okay, so these pipelines you can design this pipeline, as I said, with the help of a notebook, or you can drag and drop in the UI itself through Azure Synapse Analytics. So if you want to manage, as I mentioned earlier, you have those different sources and you want to connect to those different sources, you can connect to those sources through Azure Synapse by creating those connectors within the portal, and you can pull data from there and bring it to Azure. Okay, let me just find that slide. I know I have it. Okay, so yeah, this is the UI, right? You have copied data from a particular source, and if you click this, you're going to have, the proper all those links, all those connection strings, which you can format it. And once this runs successfully, you are saying that okay, pull this data, and then if this is successful, run this notebook. So what this notebook will have, it will have everything which you need to transform that data. So you can write code to remove a particular column. You can write code to remove the data which you don't want. Suppose you can write code to split the data into different folders. You can basically do whatever you want in order to make sure that the queries which you run are going to be efficient. So because you can write Python, you can basically do whatever you want, and then you can connect this and put it back into the data lake. And yeah, why use notebooks? You have data preparation, data visualization. You can do machine learning on the notebooks itself. You can work with big data, and as I said, you have Spark pools which you can provision for on Azure Synapse itself, so that these notebooks will run for you in the cloud. Okay, yeah, this is the customer scenario which I was trying to explain earlier, but without the slide. So now I have the slide. I found the slide. So suppose you have 10 years worth of data stored within a couple of files, and while querying, you realize that's just way too much of files that's there, which is there in your source folder. So what you want to do is you want to pull those 10 years worth of data which is within one file or within a couple of files, and you want to split it up and create multiple folders based on, let's say, year wise or month wise. So you can do that with a notebook. You can load data, put it into a data frame, and then you can do set all those different kinds of limits which you have. I think this is segregating it number wise, and then if you run this, then it pulls that data and then it divides it into different folders. So if you click, you can see this data lake. Within this folder, you have multiple folders which are segregated based on month, right? So you have multiple data, and now if you query this, you can just query folder wise whichever folder you want, and that would reduce the processing time. That would reduce the amount of data which needs to be processed when you run the query, just because you transformed it through the notebook, which is right here. You transformed it, and then you brought it in to the data warehouse in a more clear format. And just with the help of code, you can add these different naming conventions. Month 3, month 4, month 5, it has made all these different folders for you. Basically, you're just transforming the data to make it better. Right, so within this itself, as we saw in the previous slide where we were pulling in the data, we can create logic within Synapse based on if it was a success, if the pulling of data from your particular source failed, uh, or if it was a success, if it completed, it got skipped. Based on that, you can ask it to wait. You can cancel it. You can ask it to rerun. You can just drag and drop this, and you can connect notebooks to it. And yeah, and if you have this delete, you have the functions, you have some stuff, basically more properties. If you just click copy data, it will give you all the extra options which you have in order to copy data efficiently. And then you have these timers which you can put here. This is where you can set that stream or batch. If you want the how often you want this pipeline to run, you can control it just through this UI itself. Let's say if you want this to happen every, let's say, one day, you can set that timer through the Synapse Analytics portal itself. Okay, now coming to data visualization. Before going to the visualization part, maybe I can give a quick example of. Okay, yeah, I'll go through the example while going through the data visualization itself. Okay, so here when it comes to visualization, it's as you might already know, it's a graphical representation of information and data. You have all these different things like line charts, area charts, ribbon charts, and scatter charts. Basically, whatever you want, you can visualize the data in that form, and you can create reports on that data, whichever is there in the data warehouse. You can pull it to Power BI, and you can create these wonderful line charts and area charts, so that you can have that, business. You can improve your business based on those analytical features. And now once you are into Power BI, you have a Power BI app itself, which is there. You have a Power BI on Azure Synapse, as I said. So through Azure Synapse itself, you can connect that data warehouse to your Power BI, and you can filter it, and you can create those bar charts directly, or also you can do it through the app. And you have also different data sources like Excel. You can pull data from Excel into Power BI. You can pull data from SQL servers. You can pull data from Oracle. You can take XML data, JSON data, MySQL databases. You can just pull all these different data sources and connect it to Power BI, so that you can use it and create reports with it. And of course, it's flexible, and you can customize the filters which are there on Power BI. Meaning that suppose if I want data only for a particular month, then it allows you to create that those options on the UI, where you can click that, hey, I just want a report for January, or I just want a report for this one particular week. You can create that as well uh, with Power BI. And this is also inside, yeah, Power BI. Of course, there's a separate app for it, and this what you're seeing on the slide, that is Synapse Analytics. So you can connect Synapse Analytics to Power BI directly within the Azure console itself, and that will allow you to quickly create these visualizations and look at it within the Synapse Analytics portal itself. As you can see on the leftmost, you have the Power BI reports datasets. You are in, I guess, the monitor option. Uh, you have sales analytics, Power BI datasets, and within that itself, on the right, you see uh, the report itself, which is generated. Cool. Okay, this is the Power BI app. This is the standalone app. You can see it's the visualization pane on the left, on the right. Sorry, you have these different filters which you can set. You can add data. You can pull data from different sources. There are plenty of sources which you can pull data from, and on top you have data versus recent sources. You can get data. You can do modeling, and you can have more visuals, text boxes, basically. So a scenario for this can be, let's take customer support itself. So when it comes to customer support, you have different data like customer responses, you have rating, feedback, you have different metrics, you have different KPIs which are important. So first, those KPIs are stored in the source itself, and then from that source, you of course, from that main source, where you have the ratings, feedbacks, different performance indicators, customers feedback. Those are pulled. Whichever is important for us is pulled into the data warehouse, and after we pull it to the data warehouse, we can then create a Power BI visualization, which can give us an idea about, let's say, how many support cases were opened within this particular month. So I have a complete, let's say, I have a complete visualization. I can, you see, it says here, it says sales report overview, but of course, for my requirement, maybe let's say support, I can say that for a particular months overview, you can have an overview of how many cases were opened. You can have a bar chart for that. You can have the customer satisfaction value. You can pull that, and you can display it here within this Synapse itself, the customer response time, how quickly did the support people respond back to the customers. You can have all that data presented to you here within Azure Synapse Analytics. And through Power BI, of course, you can create a web link. So if you create a web link, you can give that link and give access to maybe the managers. And so the managers can see how many cases were opened, for which product these cases were opened. You can have a table, you can have a color scheming going on, you can have customer satisfaction values, whether it be red color showing that something's going wrong. If a value goes below a particular number, then show it in red. If a satisfaction is going in a good side, show it in green. So you can do all of those things within Power BI itself. Okay, so yeah, that's it. I'm coming to the end of my presentation. These are the few references which I took. Of course, it was an aggregation of multiple sources which I took to present this. I went to these different websites which you can go through as well if you want to go in more detail for the topics which I covered. And yeah, so I will go through questions.
Hey
Yeah,
Akram, can you just drop in all the reference links in the private chat so that we can drop
cool.
it in live
Yes,
chat?
I will do that. I will do that. Yeah, cool. Do you want me to do it right now?
Yes, yes, yes.
Sure. Okay. Right. Okay, so just
Perfect.
yeah, just one question, I guess. Chino Agarwal, you're asking Power BI is used for creating the charts. Yes, yes, exactly. It's used for creating charts, reports. Yeah.
Also, like you can also drop in your LinkedIn ID as well so that people can
Okay.
get connected. Varun, can you
Right.
just drop in all the links in the live chat?
Mm, Yeah, in a minute I'm dropping the links.
Yes. Akram had shared all the reference links in the lab private chat. Just drop in all the links in the live chat box.
Yeah, that's great. Sure. Yeah. So if anyone has any questions, feel free to reach out to me on
Yeah.
LinkedIn, and I'll answer your questions there as well.
Perfect.
Cool. So I guess no more questions. I think we can end it or maybe wait for a while.
I think yes, we are good to go. Like, if anyone don't have any questions, we can wrap it up. So thank you so much, Akram, for joining in today, and it was great to have you in the session. And yeah, so I hope people will learn a lot from the session and in the coming days as well. Like they can yes, whoever is watching this session, you will have the recording of the session in the YouTube channel, so you can watch it later on as well if you had missed the session or if you missed out something. So you can try it out later and you can crack your exam later. So all the best for your exam and. I hope you all will crack it. And think we usually have the quiz on our Discord servers. So think the quiz is on tomorrow, if I'm not wrong. Varun can confirm that. So just join our Discord server. We will have the quiz there, and you can win the exam certification voucher and the cool goodies through Microsoft. So, yep, Varun, can you just drop in the Discord server link as well in the chat box?
Yeah, sure. You people will be able to see the Discord channel link. It is being tickering on the bottom of the screen. screen like this bit.ly.ag Discord.
Yeah, but they will be able to join in directly through a live chat by clicking on direct, like
Give
they
me a
don't
sec.
need to
Give me a
type it.
second.
Yeah, perfect. Perfect. Just join our Discord server and we will be hosting our quiz there and you will be able to get like we usually have the quiz every week almost so you can get pretty much like we have a good community so you can interact with the people and network with the other people as well. So I hope to see you all there and thank you so much once again Akram for being here with us.
Yeah, thank you. Thank
Hope
you. Thanks so
have
much
a
for having
good
me.
day.
Have a good day. Bye bye.
Bye bye.